To start programming, let's click on the document control here and make sure we selected the ladder one, MX140, this machine to do programming, and then click on new and give a name. After we create a new file, then we import the model that we need to machine into this file. And this will be the part that we want to machine with the M140X1. Let's change the property to change the name to part. And this is a simplified features. I will set this pictures. Then I will double click these pictures to put into the body bag. To keep it inside the body bag here, right? Then let's focus on this part here. If we want to fit the stock to the part, we can always go to modify and do select this. And let's go to modify and do a string wrap here. Yeah, string wrap visible. So you automatically fit the stock to the part, right? Let's go back to the document dialog again. Set up the part. So for the material for this part, I will, let's say, put the 60 mm material. 0, let's put 1 mm extra here, and minus sign, let's put minus 100. Okay. And the height, this point to the features, how about we put 150? And then click save. Okay, so the 150 value is this one, the workpiece 0 point, the distance. So you must make sure this value is the same as your machines. Okay, the G54. For now, we can just temporarily put 150, but after you set up the part, you need to key in the exact value over here. Let's click save. Okay, that's the document dialog. How we should set up. If you want, we can always load the machine simulator to see. And I'm using machine simulator, and you can open the machines. This one, MX140 load machines, and you can see that this will be the machines, and the part is loaded to the machines. Okay, now let's do the first turning, the facing. Let's show. So I'm going to create a new cutter. This is a GibbsCAM cutter dialog. So I will choose maybe 80-degree inserts, maybe 0.8 scribe time the 12.7. Stand, let's stick up 150 and 150. And for this machine, you can either set the 2 point this way or this way. Yeah, so I'm going to set the 2 point this way. And subpositions, okay, so we need to set for these machines, we can orient the tool in a few positions like 0 degree, 90, 180, and minus 90. Okay. If you put 90, it means that the tool will rotate clockwise. Will rotate clockwise. Yeah, clockwise. 90 is clockwise. Minus 90 is counterclockwise. So for the first tool, I will not set any rotations. Just put it to 0 degree. Then let's drag into this process tile. I will do a contouring, and let's go to the home view. Okay, and then before I do anything, you must make sure under the process, this one always set to 0. Okay, we control the subposition angle from the tool. We don't control from the process because the machines, I think there's no orientations. It cannot orient. Spindle orientation is not there. So this is how the post is set up according to the documentations. And okay, so next to this 0, and this is okay. Then to select the outer contour, I can always on the span body to have a sections. Then I can always zoom in, and I want to do a front face, and maybe 10 is enough. And then I can choose this section here, drag the start point, and the end point I put as a 0. And right click here, single feature cut, then I can do it. There you are. I've done a first turning procedure. Let's go and simulate. Right? So this is 2 0 degree positions. 0 degree positions. Okay. What if I want to change the orientation to minus 90? Okay, so this tool, I'm going to create another one by click here, make a copy, and I'll put it into maybe minus 90. Okay, and I'm going to rerun this procedure and change to the second tool. Right. other, then just rerun. And we can see now the turning is on the Y. You can see now the tool has turned minus 90 degree, and okay, so this turning is on the YZ plane vertical. How about if I want to do a horizontal turning? Then I can always let me create another tool again, make a copy of the previous tool. Then I should turn it to 90 degree, and let's change the cutter and go to rotate, tab pages. If you don't see this any picture here, that means you need there's no solution found. Okay, so you can always try to click face up, and it give you some solution. If you see picture, then okay, you can rotate actually. And I'm going to turn the holder 90 degree so that I can do the turning by the horizontal. Then you just redo. And let's go missing simulation again. And now the turning is horizontal on the YZ plane. And this is G56, okay? The work offset for the horizontal is G56. For the vertical turning is G55. For milling is G54. Right, that's the late subpositions. So I'm going to rerun this one, change back to the first cutter. And let's use it back to 0. So the first procedure, I'm going to do a XZ plane turning, vertical turning for the facing here. Right, that's the late subpositions. Okay, now after we have done the facing here, next we're going to do a horizontal turning, and I'm going to delete this one, and I'm going to use my pre-save procedure to save some types. Let's save my folder. Set my folder yeah, the procedures, this folder. Okay, and I'm going to load, for example, the second horizontal procedure. This procedure I've done some settings, and also I've import and I've downloaded a turning holder from Samvik and add this one to the tool. Right, let's hide this. Okay, so this will be our cutter around insert tool. And the procedure is volume turn. This is the procedure, volume turn, and this will be the settings that I set for this part. Right. And next is to select the contour from where you to where you want to rough this part. So I'll select this one, these selections, and the starting section will be, I will again this selection, this starting section, I will locate this section here by dragging the box, and this will be the starting point. Alright, the black box is the end section, so I put it here, and the point is the end point. It's somewhere here will do. And then just click do it, and I have a program on the YZ plane. By the way, this tool is positioned at 90 degree. And let's check the rotations. Yeah, and 90 degree. So let's go and simulate. Right, so the first one is face, then to change to this tool for the volume telling. Yep, I think I hit the features. I hit the features. Let's move the part up a bit. Yeah. Let's go to body back. This, and let's move this one down. Modify and translate. About 15 mm, minus 50. Do it, and let's extend this one to 165. Right, I think now it should be okay. Okay. Face and the horizontal turn, volume turn. For this, I think I'm not going to touch this area, so that I'm going to double click. Let's edit home. Yeah, let's modify this ending section down to these sections, and this one up, and redo, so that it will not try to hit the features, or this we will use another tool to cut. Yeah, so you can always come back to edit if needed. Right, so now let's rewind and play. Okay. So that is the horizontal turning, G56. Yeah. Now we're going to do the finishing and the semi-finishing. And this one we have two cutter, the semi-finishing cutter. This will be semi-finishing cutter, and this is the finishing cutter. So we'll, of course, both cutter we are rotating 90 degree. And machine these directions, and this is start section, and this is the end section and point. Let's do it. And let's go machine simulations. So first one will be the facing. Volumill, nothing. And it will be the semi-finishing. And finishing. Now let's look at the code, and let's select all the procedure and go to post. Let's use this option here. Yeah, post, and choose the post, brother post, and select your output path, and then okay, I will post everything here and just post. Okay, you might have some message here, some incorrect tool loaded for tool number 2. Why? You can see that the first tool is T1, and the tool number 2 we have two number error here. To solve this one, because this tool here we already have the ID1, so I'm going to change this one also ID1, so let's change it to 4. Yeah, and let's pause again, and now it's okay, right? Now T4. And let's look at this one. Okay, the work offset. The work offset inside this used inside this G code that is fixed in the post. We fix G54 for milling, G55 for vertical turning, and horizontal turning is G56. So for the first two is A0. A0 is vertical turning, so it will use G55. For the second two, A minus 90, so it will use G56. Right. That's the code. Okay, this picture here explain how you should set the G54, 55, and 56. G54 is for milling, G55 is for vertical turning, and both of these work offsets set at this point here. And G56 will set at this point. Okay, next we're going to do some milling. Let's remove this procedure. Before I continue with the milling, I'm going to run the machine simulator again. Select everything. Let's fast forward. So why? Because I want to save the stock of the lathe for the milling for the next procedure. To do that after the simulation, you can always right click and select the create facet body, right, and immediately you have a facet body here. Let's off the cam, off the profiler. Let's go to property, so I can say this one stop after turn. I can set this one as my stop, so that for the next time I can straight away start the simulation from this stage here. Stop, and I put this one to the body back. Let's go back to cam. Yeah. For next step, we're going to do some roughing on the ID by a 3-axis mill. So let's change to the XY plane, and I'm going to load my procedure. Okay, I'm using the 5mm8 flat mill. Then I'll on the slicer, drag, and I'll select the solid model with this boundary here to do the roughing and finishing at the same time. I forgot to set something, I think. Yeah, I must change this plane to XY plane. Yeah, XY plane. So the height of the contour here and here. For this one, from 0 down to this one. Let's do it again. And I forgot to select this boundary. And now it's done. This is a Volumill. And a finishing. And for this milling, let's pause and see the code. Select log. As you can see, it is using G54. So for all the milling, you use the G54. Okay, next we're going to cut the slot on the top here. So let's delete this one. Let's go to slot procedure. And let's select, drag this one and select here, start point somewhere here, end point somewhere over here, and single feature, and make sure I'm using XY plane. About the depth, let's click Alt and the key to capture the depth here. Yes, correct. And right, I'll put 0 here first. Okay, this is one slot. So if I want to copy, make a copy, then I can say, okay, 60 degree. I want to have 2 more copy, right? Then give me three more pass. And let's go simulate. This is a slot. Let's simulate all together. So this will be a roughing. And slot cutting. It's a bit fast here. Let's look at the slot, because I use this copy. I use this copy to 60 degree. So when I post the code out, the result will have some subprogram. So this is the subprogram, and this is calling of the subprogram. Okay. So if you don't like this way, you want to have don't want the subprograms, there's another way that you can do. You can always come back here. Don't do this 0 copy. Just make one copy, right? And then with this one, I can go and go to plugin. Select the TP transform. Here, TP trans, and 060 and 2 times and XY plane, and I'm gonna select this operation and click do it. It will give you the same result. But if you post this one out, there's no more subprograms. Okay, so there's 2 options here. You can choose which one you like. So let's change back to here. Here's this a few tab pages to organize your procedure, process, so or operations. Select this one. Let's delete these transformations. I don't want this. Add this one back to this one 2 times. I will use the subprogram. Okay, now let's make a hole through this center here. I can, let's my procedure Helix Bore. Yeah, this one. So I'm going to use a drilling procedure, and XY plane is good. I'm not going to use any cycle. I will use a Helix Bore, also bore, and this is a pitch. You can put 2 if you want. And from the top, click alternate. This will be my top. That's a minus 16.5 to, I don't know. I'm going to okay, drill until somewhere here. So I will edit minus 5. That's over it. And then what I need is to select the circle, use a section profiler, then click OK, and I will have my helix path through the hole. And let's do simulation. Let's rewind. This is roughing. Slotting, and finally the helix bore. Okay, done. I'm going to save this one, create facet body, and I'm going to save this one, show property, stock, up, 01, this book number. So I'll put this one as my stock, and let's put it to the body back. So for the previous one, let's change the property back to part. So now this will be my stock. Okay, now let's delete this. Now we're going to machine this flat here. I'm going to use ZX plane. Will do. Okay, let's temporarily off this profiler. Go to this side. You can see that is tapered 5 degrees. Okay, so to do this machinings, we cannot use the existing default CS, so we need to create a new CS according to this flat face here. To do that, let's click on the CS here. So we'll click ZX and just click a new, so you'll make a copy of the ZX plane. Put, let's say 5 degree, the name. After you put the name, the next I want to use, click the CS palette and okay, make sure you select the face selection. So I just select this face and click on this. It will modify the plane to parallel with this flat. Okay. Then we can do our machining. So we'll go and load the procedure. Yeah, index mill. Right. Just turn on the profiler. Or maybe we just pick this one, pick the whole thing, and remember to set the plane to the 5 degree plane, right? The height, this will be the height. Yeah, the height's okay. Yeah, remember to change the plane. And then let's on the profiler, so then we can select this profile and click OK. Okay, let's put 0 first. Redo, right? So it's doing one side. So after it's good, then you can make a copy. And it will be looking like this. Let's simulate. Yeah. So this is the 5-axis index milling. Next, we're going to do a 4-axis milling on this face here, right? On this face. This is actually a this face. This is a 3D face. It's not flat. I'm going to do milling on all of this face around. 4-axis simultaneous milling. To do the 4-axis simultaneous milling, the first thing that you should do is change back to CSXY. Okay, for 5-axis, always use the XY plane. So let's load my pre-save procedure. Yeah, this one. And for this one, I'm using a ball nose tool. Right. To do the milling here, before we select, we need to extract the edges out. So let's create a new group and put this for X. Okay. Let's, so that all the geometry that we're gonna extract this edge. And also double click on this. We will select the whole and right click, extract edges and do it. So this edge and of the edge display. So this contour will automatically put into this workbook. Yeah. It will help to manage the model clean, make it clean. Yeah. So the machines, this is a procedure. Of course, you can set your RPM fill rate, whatever you need. For me, I just ignore it for now. So let's go the surface path. So I'm going to use a mode between two curves. So dry face. The dry face will be this face. Right? Okay. And the first contour will be this one. The second will be this one. Right? And some other settings. Let's go to link. I'm going to change my retract using a cylinder type and parallel the z-axis. Radius is 60 for clearance. I think enough. For the rest, I'll use the default. Yeah. Then for 2-axis, this is very important because this machine is 4+1. It cannot go full 5. Yeah. So that's why you need to select 4 axis. Have to select 4 axis. Then the rotary axis, then you have to define. Okay. Of course, the rotary axis will be the z-axis. Z-axis. And you can always make the 2 point to the z-axis, the center. We'll try this option later. I'm going to cancel this and just to show you what's the difference. Yeah. So if I use on this one, basically only the machine will move the C, Z, and Y. Only 3 axes is moving. Yeah. So if I use this 0.2 to rotary, and I'm going to index the A axis at 45 degrees. And just do it. Right, here's the 2 part. And looks a bit funny. Ah, okay. Right. Why you can see that I make a mistake, you know? This is something wrong here. This is all because I selected wrong CS. So please make sure you select the XY, yeah? And now it's okay. Now it's okay. And you can go and do the simulations. Let's zoom it. As you can see here, this will be the 4-axis move. For 2, it will move only the Z, Y, and C 3 axes, because we request GibbsCAM to point the tool always to the center of the rotation axis. Right. Just in case if you decided not doing that, don't want to do that, so let's go to axis and go here, cancel this one. If you cancel this one, there will be a 4-axis movement, XYZC movement. Yeah, let's simulate and you can see the difference. Let's select this one also. This will be the 4-axis move. This is a 4-axis simultaneous cutting, just to show you the movement. You can see the C, X, and Y and Z keep changing. So if we try pause, you can see that XYZC. Yeah, this is a 4-axis simultaneous movement. Okay, now let's do a rotary mill for this 2 pocket here. First, let's change to YZ planes. Most of the time, you do rotary mill on the YZ. And that's why I change to YZ. And let's create a new work group for it. Call rep. Yeah. And I'm going to extract the click it. No, not this one. This one and this one. Use Control key to select 2. And extract edges to it, and let's off this edge display, and let's check what is the radius for this part. Go to show positions, and you can change this one to radius curvature, and pick this face. It will give you radius 12. Okay, let's put it into the body back, and let's focus on this. Okay. So now this curve is wrapping around this radius 12 cylinder, so we need to unwrap this curve. Let's Control A, select all of this curve, and then go to unwrap geometry. Unwrap, and this value should be 12. Good. Right. So now the curve already become 2D flat. Right. So if you want to wrap this curve back to the part, this is easy. So you just right click this info, change to wrap. Okay. After you set to wrap, then you can use this icon here to wrap and unwrap the wire frame as you wish. Yeah. So let's work on this. Let's hide to the body back. Now I'm going to do a pocket on this. So I'll use a rotary mill. Right, so I will choose first, make sure it's YZ. Let's do 1 time first, 0. YZ plane, and make sure you choose. Let's choose the position first. Yeah, and the settings, the height, so I can capture this height. It is 12 mm for sure. No. Which plane? Make sure you select the YZ plane here, because we're going to use YZ plane to machine. And the height again, let's alternate to capture the height of this point. So it's 12, so I'm going to go in for 6. I think enough. And passes, maybe I put 3 passes. I'm going to cut 2 times. And then just select the contour and do it. There you are. I have a flat pocket now. Right? To convert this flat to a rotary, you just click here, polar and cylindrical milling, and redo, and you will wrap around the part like that. Right, and let's copy 1 time, 180. Right, so let's wrap back the geometry. So this is how you do a rotary mill, and yeah, let's show back this part so that you can have a clear picture how it works. Right, so and we can go for simulations. Let's rewind. this is rotary mill. We cut by moving the Y, Z, and the C axis together. Right, that's it. You can post the code to see. Let's post the code here. See, YZC, YC, YC, YC. This is a rotary mill. Okay, next we're going to do some engraving on this face here. So let's hide this part and let's unwrap the geometry and go to home view. And I'm going to create a text, a geometry, and go to this one. So if you want a single line font, this looks for the Mopak. This is a single line font from GibbsCAM. So I pin a MyGrowTech, then I will put at radius 12. So same level as this contour here, and just do it up again. Do it right. So this is my contour. Let's go to home. Next I need to move this shift key, select all, and control alternate key, then I can rotate the text to roughly the place that I want and move. Select the arrowhead, then I can move. And let's say I will locate this text to be somewhere here. Maybe move out a bit. Yeah. Okay. So I'm going to use this text. Now this white purple color. Purple color means that this curve, the text curve, is not belong to this YZ plane. So if I want to make it all belong to YZ, I just go to modify and change N5G. So now it becomes blue. It means it belongs to this active plane. Okay. So next step is to do a engraving here. So I will delete this. Let me load the engraving procedure. It's just a contour procedure, contouring procedure, and of course just make sure this is YZ plane. No copy, 0 copy, and the height 12, 11.7 is okay, just 0.3 mm tabs. Nice. And the cutter is a 90-degree cutter, 90-degree drill. Yeah. and I can use shift key, select all of this contour, and then just click do it, and as you can see, it wraps around the cylinder because I use the polar. If I use position, it will be flat. It will be flat like that, right? So this is what I need. And then I can wrap the geometry to see, right? So I'll do that, and we can do the simulations. And this will be the engraving. There you are, MyGrowTech. Okay, next let's go back to the first web group and let's display the art. What else that we need to machine? Okay, so we need to do some machining for this here, this pocket here. So how to do it? I'm going to use the FX command to do it. So again, to change when to fix my plane. When doing FX, it's good to use the XY. And before I do this, I need to create this edge here. So let's extract this edge. Right. Then let's load the procedure. Cone pocket. Okay, I'm using a flatten mill tool, 210. That is 210. That's MU6. Okay, and copy or no copy? Okay, I will do a copy and surface path. Let's do zero copy first. The surface path, and I'm going to use projections. There's a lot of function here. Project curves. Okay, dry face. This will be my dry face. And project curve. Yeah. Project curve. Let's select this one. Okay, this direction, so I want to offset left for this direction. And what else? Two axis. I'm going to use a 4 axis and only 2 to rotary, and set the axis to 35. This is good. And we're going to do some cow check as well. Check the tip. So if all cut, the drive surface retract along 2 axes. And also more pocket, we need to do a pocket. Okay, if I don't on this, let's do it. I think I forgot to set the CS, yeah, change to XY. Right, this is what we want. Looks good, right? And this is without the more pocket. So now I will change to on the pocket, and the size step we can set, and okay, and just redo, and we'll have some size step on this part. And also I will do a copy 181, and yeah, and let's do a simulation for this. Okay, so that is the pocket. Okay, next I'm going to show how to do a YZA machining, A-axis, using an A-axis to make a groove here. Yeah. Before that, let's create a geometry. Let's create a new workgroup for this. And I'll use ZX plane to create sections. Select this, extract. Right. And now let's hide this. So I will delete this section away. I'm not going to use this one. This one. This one. reconnect back this circle. Connect. Yep. Okay, so to do the 4x milling, we change to XY. Yes, we will use XY. And let's load the procedure. And I'm using this tool. Yeah, it's a sharp tool actually. Okay, so I'm using this 90-degree tool. And make sure this is XY. Yeah, we can make a copy, one copy, and the surface path. And we'll use the projection curve and dry face. So this will be my dry face. And project curve. This will be my curve. 2 axis. I'm going to use a 4 axis, but this time I change the 3 axis to Y, so that I can use the A axis to machine. And that's it. Let's click OK. And we have the 2 parts here. And now the cutting is Y, Z, and A axis. Right, that's it.